Okay, so I'm going over the Unit 9 more gas law problems involving moles worksheet. So number 1 says, what's the pressure of a gas inside a 1250 milliliter balloon that contains 3.4 moles of gas at 20 degrees Celsius? So I'm given volume, moles, temperature, and I'm looking for pressure. So this is a simple PV equals nRT problem. We're solving for pressure, so we're going to say pressure equals nRT over V. And we just have to make sure that the units we plug in here fit our R value in terms of the units. So just to recall, R equals 0.0821 liters atmospheres over moles Kelvin. Okay, so let's see. Moles were good. Temperature, I'm given 20 degrees. We need to convert that to Celsius. 20 degrees Celsius. Add 273. We'll call this 293 Kelvin. So now we're ready to plug that in. For volume, I give you 1250 milliliters. We need to convert that to liters. So that's just going to be 1.25 liters. So we're ready to plug everything in. Just get that out of there for now. All right. So pressure equals N, which is moles, 3.4 moles, times R, times T, which is 293 Kelvin, divided by my volume, which is 1.25 liters. Mole cancels mole, Kelvin cancels Kelvin, liter cancels liter, we're left with atmospheres. And when we do the math, we get 65 atmospheres, 2 sig figs. Okay, number 2. What volume would 342 grams of argon gas occupy at 720 torr of pressure and 131 degrees Celsius? So let's see, I'm given grams, which I'm going to convert to moles. I'm given pressure, and I'm given temperature, and I'm looking for volume. So another simple ideal gas law problem. PV equals nRT. This time I'm solving for volume. Volume equals nRT over P. And again, the units have to be converted into the appropriate units to plug in here. So let's go grams to moles. So 342 grams of argon times 1 mole over the molar mass of argon, which is 39.95 grams. Gram cancels gram. That gives us 8.6 moles. Let's see. 720 torr, that needs to be converted into atmospheres. 720 torr times 1 atmosphere over 760 torr gives us 0.947 ATM. And let's see, 131 degrees Celsius has to be converted into Kelvin. So 131 degrees Celsius plus 273 gives us 404 Kelvin. Okay, so now I'm ready to plug all these values in. So V equals nRT over P. So my moles is 8.6 moles. My R value is 0.0821 liters atmospheres over moles Kelvin. Let's see, temperature is 404 Kelvin. We can divide this by my pressure, which is 0.947 ATM. That's a mistake I made. Anyway, we do this out and we get, what am I solving for here? Volume. So it should be liters, right? I'm just going to double check my math here. I don't trust what I wrote down. 8.6 times 0.0821 times 404 divided by 0.947. Okay, so I get 301. We want to make sure our units work. So let's see. Mole cancels mole. Kelvin cancels Kelvin. Atmosphere cancels atmosphere. We're left with liters. Okay. So my answer is 301 liters, but looking at sig figs, I need to report 2 sig figs. The only way to do this, 3.0 times 10 to the second liters. And that's my answer. Okay, number 3. So we have a mixture containing 10 grams of each of those 3 kinds of gases at STP. Calculate the volume of this mixture. Okay, so since it contains 3 different gases of different grams, or the same grams, what I need to do is convert all of these to moles and then add up the total moles. So I won't go through all the calculations, but for nitrogen, using molar mass, it turns into 0.357 moles. For water, you get 0.555 moles. And for krypton, you get 0.119 moles. So that's how many moles of each, but I need the total moles, so we add it all up, and we get 1.031 moles. Okay. Now at this point, I can go one of 2 ways. I'm looking for the volume. So I have N, I have temperature, which is standard temperature, 273 Kelvin. I have standard pressure, 1 atm. I could plug it all into the ideal gas law. Or I could take the shortcut. Because this is at STP, we know the volume of this many moles. So I'm going to take the moles times my volume per mole, which is 22.4 liters per mole. Mole cancels mole. And remember, this only works at STP. If the problem didn't say STP, you couldn't use this. Anyway, we do the math, and with 4 sig figs, because that's what I'm given in the problem, 23.09 liters. Okay, number 4. If you capture 37 milliliters of hydrogen gas in a tube at 19 degrees Celsius and 1.05 atm of pressure, what volume would the gas occupy at STP? So this was actually related to the lab that if you're watching this from Chem Period 1, you haven't done yet. So we can still work it out. Okay, so anyway, the volume is 37 milliliters. The temperature is 19 degrees Celsius, and the pressure is 1.05 atm. And what I want to do is compare this to the conditions that would exist at STP. So really what I'm doing is I'm saying if the initial volume, temperature, and pressure are this, what are V2, T2, and P2 going to look like if these are our STP? So standard temperature is going to be 273 Kelvin, and our standard pressure is going to be 1.00. You could just say 1 for this, but just don't limit yourself with sig figs. And that's atmospheres, and this is what I'm trying to solve for. What would the volume be at these conditions? So even though we've been doing a lot of stuff about the ideal gas law, this problem we're in fact going to use the combined gas law. One thing I need to do here, degrees Celsius has to be in Kelvin, so that is going to be 292. So P1 V1 over T1 equals P2 V2 over T2. We are solving for V2, so V2 is going to equal, let's see, I'll write these first, P1 V1. I need to divide by P2. T1's already down here. And this is going to get multiplied over here, just like that. Okay, I always prefer to do it this way because we can see the units canceling out nicely. Let's plug in our values. So P1 is 1.05 atmosphere. V1 is 37 milliliters. And you might say, wait, don't we have to convert milliliters to liters? No, that's only in the ideal gas law. With combined gas law, whatever units you feel like putting in, it's just going to be the same units you get out. The only one that you have to make sure of is temperature must be in Kelvin. T2, 273 Kelvin. Divided by T1, 292 Kelvin. And, where am I? P2, 1.00 ATM. Check our units. Atmosphere cancels atmosphere. Kelvin cancels Kelvin. We're left with milliliters, which is correct. Do the math. And with 2 sig figs, because my volume is 2 sig figs, 36 milliliters. Okay? And if you're watching this and haven't done the lab yet, this is the type of calculation you're probably going to have to do during the lab.